Hey guys, welcome back. In this video, I'm gonna discuss about the problem which I wasn't able to solve in Codeforces around 943. During the contest, I was able to solve five of them, and the last three problems, F, G1, and G2, I wasn't able to solve, and I tried to upsolve just now. And in this video, I'll cover how to solve the equal XOR segments F part, and so let's get into this video. Basically, the equal XOR segment says that we have an array x1, so x1, x2, x3, so on till xm, and it is called interesting. The term interesting. If the array is possible, if it is this segment is possible to be divided into a array into k parts where k is greater than 1, so that bitwise XOR of values from each part are equal. See, this array is given, and it is called interesting if this array can be divided into k parts where k is greater than 1, and I mean, first one part means half of it, where k is greater than 1 means 2 part, 3 part, like that. And bitwise XOR of each part should be equal, like all the parts should be equal. And yeah, problem doesn't end here. Basically, what they are giving is they are more formally they are just explaining what I just said now. What is the bitwise XOR here for what is the problem basically. And in this problem, what they will give is they are giving the input t, which is as usual the number of test cases, and next one is n and q. N is the size of the array and q is the queries in the sense. And the next line they will be giving the array length, and third line, which is the third line, first is n, q, and after that arrays, and after that followed by queries, q queries. Like q is 5, we will be getting 5 queries, where each query represents indices L and R, where L and R, L to R, like 1 to 5, array length from 1 to 5, 5 is the last, and 2 to 4, second element to fourth element, and 3 to 5, third element to fifth element, something like that. And what we need to do is in each query given L to R, we need to say whether that query length of the array is interesting or not. Understood, right? It's basically easily this question is easily can be understood. Let's say from 1 to 5, from 1 to 5 this whole array should be interesting, and 2 to 4 in the sense second element to the fourth element, this array length should be interesting, and 3 to 5 third element to the last element should be interesting. Basically, for example, 1 to 5, first element to the last 1 1 2 3 0, they have already said how it can be made interesting, like how many segments they are dividing into k equal to 3 segments. And so in the XOR of 1 is 1, here 1 is 1, 2 3 0, XOR of 2 3 0 is what? What is the XOR of 230? It is also 1. So XOR of all three segments are equal. So basically, XOR has quite a few formulas. I'll just tell you. Made a note as well. Yeah, these are the XOR formulas. Just make a note of this thing, or you can save it in your editor as I did, and same like me. XOR of A and B can also be written as XOR of B. A XOR B can also be written as B XOR A. A XOR of B XOR C can also be written as A XOR B whole XOR C, or A XOR C whole XOR B. This is kind of like associative property, this is a distributive property, something like that, something how it comes in addition subtraction, right? Something like that. And these two are quite important. A XOR A, XORing with the same element gives you 0, and XORing with 0 gives the element back. Understood, right? XOR A XOR 0 is A XOR A is 0, and A XOR 1 will give you A minus 1 if A is odd, and it will give you A plus 1 if A is even. So basically, if you just remember these things, any XOR sum can be solved, at least the basic funda of part of it. So if you are more interested into the learning the bitwise operator, then you can check this video from the Priyansh Agarwal TLE Eliminators. Learn this 10 bitwise tricks or regret later. This is quite helpful. So coming back to the problem, how you can solve this is, so it's just made easy by me. So let's say initially what they're giving is nnq. I'm getting a nnq. I'm creating a map int of vector. You know what is map, right? It stores key value pairs. Key will be there, and then values will be there. But the thing I create for this thing, map of int comma int, but the thing I created is map of int comma vector int, which means one key. For a key, it will be having vector of values a comma b, like this, a comma b comma c. For a key, values will be a vector. Understood, right? For another key, values will be another vector. Size is not known, it can be of any size, but map of int comma vector int means for a key, value is a vector. So I'm pushing the initial for key 0, I'm pushing the value it as 0. This is the base condition, it is self-defined. And coming back to this thing, while accepting the arrays, I'm creating an array of length n, C in A of I. As soon as I did C in A of I, I'll be getting XOR of A of I with A of I minus 1, which means if I write it like this, A of I is equal to A of I XOR of A of I minus 1. That's what it means. Like the current element, I'm not interested. I'm interested with the XOR of XORing with the previous value. So if I by default array, if it is not initialized, like say you might get doubt if it is I equals to 1, I 1 with the XOR of A of 0. What is A of 0? Since I have not defined, it will be 0. So A XOR 0, what did I say? A XOR 0 is A. So basically the same rule applies here. A of I XOR of 0 is A of I itself, and I'm creating a key with this thing A of I and push back. I'm pushing the ith index. Basically, if you note it here, what segment I'm creating? Segment at that particular point, at each and every point, segment at 1 interval. So that's what basically I'm doing here. Key of A of I push back with the ith index. Now, once I did this thing with the segment at each and every interval of the array, like each and every indices, and next let's go to the q queries. Like while q minus minus will be reducing the queries, and I'm getting the accepting the input L and R range. Let's say if if by lucky a of R is equal to A of L minus 1, basically, which means XORing till L minus 1 came out to be equal with XORing with A of R, then obviously it will be solving the condition for array to be interesting, like segment till L minus 1 XOR and segment till R XOR is same. Then I can just say that yes, the array is interesting. So if it is not, then what will I get is I will be getting the lower bound from key. Basically, if you are not aware of what is lower bound, and you can go through this Geeks for Kicks article of the lower bound. Basically, I give you a recap. If a lower bound is a function where this lower range is given, upper range is given, and within this lower to upper range we need to find this value. Understood, right? And once the first value is found, that lower indices where, like, let's say this val is repeating all over the array, the first index where it is repeating, that is the lower bound, lowest most bound, not upper bound. In the sense, upper bound is also there, and it will give you the last occurrence of that value. And I will be attaching this geeks for geeks article of the lower bound in my video. You can go through it line by line. So coming back, so as you know that, see, a of l minus 1, a of l minus 1 means the XORing till l minus 1, and I'm putting it inside the key of l minus 1, which means, what did I say, key till values, key value, key at XORing till l minus 1, it will be an array of values, which array of what, indices, where and all the l minus 1 XOR was achieved. And I am running it from that array. L minus 1 will have this thing, the arrays, and beginning of the array till end of the array. And what am I searching for? The value r. I'm searching for the value r. It should end at the indices r, that index r, whether it is present at the XOR of a of l minus 1 in this key. Similarly, I'm finding the another lower bound, a of r, where XORing till a of r and putting inside the key, it will give an another vector, begin dot end. I'm searching the value l and getting the lower bound. And if left lower bound, you will, this is an homework, what is this symbol, just find it out on your own. It's an homework. If not, I will mention it in the comment section, whoever asks it. Left is greater than the right, which means the lower bound of the left, like ending till r, if that position in the array becomes greater than the right, like that's l. If l comes here and r comes there, then array is definitely interesting. If this condition is satisfied, then you print yes. If it is not, then print no. That's it. Basically that's it. I'll share my solution in code also in this video. Thanks for watching this video, and hopefully you can expect for the next video for the next problem. Basically it is division plus LCP easy version. Thanks for watching this video. Bye.